In geometry, we learned that parallel lines were two lines that never intersected. In algebra, two lines are parallel if their slopes are the same. Perpendicular lines were two lines that intersected at a right angle. In algebra, we learned that two lines were perpendicular if their slopes were opposite reciprocals. So in example 7, let's find the equation of a line parallel to a given line. This is the symbol for parallel lines. I like to use symbols for things when I can, so note that that means parallel lines. I want to find the equation of a line that's parallel to 4x plus 6y plus 5 equals 0, but it passes through the point 5, 2. Well, if my line is parallel to 4x plus 6y plus 5 equals 0, then it must have the same slope. So why don't we find the slope of that line? To find the slope of the line, I'm going to start by moving the 4x and the 5 to the other side. And then I'm going to divide everything by 6. Don't forget I have to reduce fractions. Now, the only thing that I need from this particular equation is the slope, because in order to write the equation of the line, if you know a slope and you know a point on the line, you can use point-slope form. So the slope of my line must be negative 2/3, and my point is 5, 2. So we're going to plug into y minus y1 is equal to mx minus x1, where 5 gets plugged in for x1, 2 gets plugged in for y1. So y minus 2 is equal to negative 2/3 x minus 5. Now that's in point-slope form. What if I wanted to write this equation in slope-intercept form? I would first distribute the negative 2/3, and then I would add 2. And that would be slope-intercept form. What if I wanted to write this equation in standard or general form? I would add the 2/3, I would subtract the 16/3, and then I would get rid of my fractions by multiplying everything by the least common denominator, which happens to be 3. So if I multiply everything by 3, I get 2x plus 3y minus 16 equals 0. And this is general form. So depending on which type of equation I asked for will depend on which equation you would give me. And it would be one of these three. So in example 8, let's show that the points P at 3, 3, Q at 8, 17, and R at 11, 5 are the vertices of a right triangle. All right, when you're given points in a geometric interpretation, if I were you, I'm not, but if I were, I would draw a picture. I'm actually going to redraw this just a little. All right, so one of my points is at 3, 3. That's P. Q is at 8, 17. So 4, 5, 6, 7, there's 8. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17 would be up here somewhere. And R would be at 11, 5. So 8, 9, 10. There's 11. 1, 2, 3, 4, 5. So around here somewhere. So just by drawing this picture, you're probably going to think, well, maybe my right angle would be here. So if this is a right triangle, then QR must be perpendicular to PR. So if I find their slopes, they should be opposite reciprocals. Well, let's do that. Let's start by finding the slope of QR. So remember, in order to do the slope, it's change in y or change in x. So I'm going to do 17 minus 5 over 8 minus 11. Remember that order matters. These two and these two better match up as ordered pairs. All right, so 17 minus 5 is 12. 8 minus 11, negative 3. So I'm going to get negative 4 is the slope of QR, and here's my line for QR, and it looks like it's going down from left to right, and it's pretty steep, so -4 as a slope makes sense. Now let's do the slope of PR. Okay, so let's do 3 minus 5 over 3 minus 11. 3 minus 5 is -2, 3 minus 11 is -8, and I get positive 1/4. Well, look at that. Those two slopes are not only opposites, but reciprocals. And here's PR. It looks like it's going up from left to right, so positive makes sense. And the fact that it's not very steep means that 1/4 makes sense. And since they're opposite reciprocals, it must be a right triangle. Now let's find the equation of a line perpendicular to a given line. So I want to find the equation of the line perpendicular to 4x plus 6y plus 5 equals 0, but this time it's got to pass through the origin. Now, we actually did this earlier in problem 7. We found out when you solve it for y, 6y is equal to -4x minus 5, so y is equal to -2/3 x minus 5 over 6. It's just this time, if my new line is perpendicular to the old line, that means the slope of my new line is the opposite reciprocal. And then it passes through the origin, which means it passes through 0, 0. So let's start by using point-slope form. So in point-slope form, the equation is y minus 0 is equal to 3/2 x minus 0. Well, that's pretty easy to simplify and put in slope-intercept form because it's going to be y is equal to 3/2 x. To put that into general or standard form, I'm actually going to subtract y this time. And the reason I'm going to do that is because I always want the term in front of x in general form to be positive. And 0 equals 3/2 x minus y is the same thing as 3/2 x minus y equals 0. I don't like fractions, so I'm going to multiply everything by the least common denominator, which is 2. So I get 3x minus 2y equals 0. So that's general form. This is slope-intercept form and point-slope form. Now let's talk about a family of lines. Use a graphing calculator to graph the family of lines y equals 0.5x plus b, for b being equal to -2, -1, 0, 1, and 2. What property do all the lines share? Well, I'm actually going to plug each of these into my calculator. So I'm actually going to plug in 5 different equations. When I do that, this is what I see. Well, why are they all parallel to each other? They're parallel to each other because they all share the same property, which is that their slope is 1/2, which is the same as 0.5. So remember, if the slope is positive, all the lines should go up from left to right. And since the slope is 1/2, the line shouldn't be very steep. In real-world application problems, the slope of a line is really just a rate of change. For example, there's a rate of change that you're all familiar with. You're all familiar with how fast vehicles go. Miles per hour. That's how fast something's going every hour. It's a rate of change. Or maybe you want to know how many gallons per minute you're using in your vehicle. Gallons per minute is a rate of change. Both of these rates of change are just slopes of a line. Let's do a real-world application problem using rate of change. A dam is built on a river to create a reservoir. The water level W in the reservoir is given by the equation W is equal to 4.5 T plus 28, where T is the number of years since the dam was constructed, and W is measured in feet. Sketch the graph of this equation. What do the slope and W-intercept of the graph represent? Remember, in an equation, we're not necessarily going to use x and y. Sometimes we're going to use variables that represent what the variables really mean. So like T is time and W is probably water level. So in order to sketch a graph, what I would do is I would start with the easy stuff, like what's the w-intercept? Well, the w-intercept is 0. When t equals 0, w is equal to 28. And then maybe I need one more point on this graph. And I'm probably not going to pick 1 just because 1 is too close to 0. So maybe I would pick 2, 3, or 4. So just for the purpose of this problem, why don't we pick t as 2? So if you plug in 2 for t, 4.5 times 2 is 9. 9 plus 28 is 37. So now I've got two ordered pairs, where this is like your x-coordinate, this is like your y-coordinate. So now when I go and graph this, maybe I'll do 1, 2, 3, 4, 5 on my t-intercept. And my w-intercept, I got to scale it different because I'm not making 28 and 37 tick marks. So maybe I'll go 10, 20, 30. And I realize that it's not the best drawing, but I only need a sketch of it. So to kind of get an idea of what this looks like, 0, 28 would be about here, and 2, 37 would be about here. So the line looks like this, which makes sense because you're filling the reservoir up, so you hope the water level's going up. So the next question was, what does the slope and the w-intercept of the graph represent? Well, let's start with the w-intercept. The w-intercept was 28. That means when I first created this dam, the water level started at 28 feet. So the w-intercept is the water level started. Now my handwriting is looking really bad here. Let's see. I'm going to pause this and write it so it doesn't waste time. All right, so the w-intercept, that's the water level that my dam started at when I created the dam. So it started at 28 feet once I finally finished building it. The slope is 4.5. 4.5 says that the water level increases by 4.5 feet per year. Remember that the slope is a rate of change, and since the water level is in feet, the time is in years, that means the slope is going to be in feet per year. Let's do one last real-world problem, a science problem. As dry air moves upward, it expands and cools. If the ground temperature is 20 degrees Celsius and the temperature at a height of 1 kilometer is 10 degrees Celsius, express the temperature T in degrees Celsius in terms of the height h in kilometers. Assume that the relationship between T and h is linear. All right, so if it's linear, we use y equals mx plus b, but here's the problem. Y and x are not our variables. Our variables are T and h. So we're instead going to write this as the temperature is equal to the slope times the height plus the y-intercept. They actually told us the y-intercept. Let's go back up here for a second. It said if the ground temperature is 20 degrees Celsius, that means when the height is 0, the temperature is 20 degrees. Well, if I know that, then I can find out what B is. Or M, I guess I should say. No, I'm going to solve for B because what's M times 0? It's 0. So B must be 20. So now I know the equation here is T is equal to MH plus 20. All right, now I got to find out what the slope is. They actually gave me one other ordered pair, didn't they? They told me that at 1 kilometer, the temperature is 10 degrees Celsius. All right, let's go back here. 10 is equal to M times 1 plus 20. So negative 10 is equal to M. So this makes sense because the higher you get, the temperature is falling because the air is expanding and cooling. So T is equal to negative 10H plus 20. is the equation that represents the relationship between the temperature and the height. Now let's draw a graph of the linear equation and determine what its slope represents. So the slope we determined was -10. That means that the line should be going down from left to right. Well, let's do it this way. So at 0, the height, the temperature was 20 degrees. So we're going to put temperature here, we're going to put height here. So maybe I'll do 2, 4, 6, 8, 10. And we knew that at, sorry, I should not have done that. Let's do that again. Let's see, not 10, I want it to be 20. So let's see, 4, 8, 12, 16, 20. It really doesn't matter how I scale it. I could have done tick marks 1 to 20. I could have done it in 2s. I could have done it in 5s, but I had already drawn those tick marks, so instead I went in 4s. Okay, then I decided that at 1, the temperature was 10. As a matter of fact, if I try 2, I'm going to find out the temperature is 0. So here's my line. What does the slope represent? Well, the slope is -10 degrees Celsius per kilometer. That means it's dropping 10 degrees Celsius per kilometer. So now I've got it written out as a nice sentence. The last thing that we're going to do is we're going to find the temperature at a height of 2.5 kilometers. All right, so I know I have this equation. Well, if I want to find the temperature at 2.5 kilometers, I'm just going to plug in 2.5 for h. So the temperature is equal to -10 times 2.5 plus 20. Well, -10 times 2.5 is -25, and -25 plus 20 is -5 degrees Celsius.